Hi, Math 1 students. This is the Module 9 3A.1 remediation video, and it's really using the line of best fit, also known as the regression line. And in most of these problems, almost all of them, 3 out of the 4, you will be given the regression line, and plain and simply, you will just be asked then to use it to make a prediction. So let's take a look at number 8. And by the way, this is from the Module 9 Summative Review. It's at the back of your yellow packet. And I'm just jumping to these problems that are focused on this proficiency on 3A 9.1. It says the scatter plot shows the average number of Snapchats sent each class and the average number of problems completed for each class. And the regression line is given to us. So the nice thing about this is they're giving us a regression line. I guess what you need to do is to very much pay attention to the x and the y axes. The x is going to be the average number of Snapchats sent, and the y, of course, is going to be the average number of problems completed. So remember what a regression line is really doing, a line of best fit. It's really there to approximate this relationship that we're seeing. You're seeing a whole bunch of points here. These are actual data points that would have been collected. But this regression line is just there to make predictions. So they're saying in number 1, or I should say number 8A, use the regression equation that we have here to predict the average number of problems completed by a student who sends an average of 4 Snapchats. Well, I hope what's happening is you can see that when we're talking about Snapchats, we're talking about x. So we have x is equal to 4. Now, of course, what you're probably going to notice is there appear to be 3 actual data points that we have collected, but that's not what we're asked to do right now. We're using the regression equation. We're trying to get this point, if you would, on the regression line. And, we have 3 actual data points that would have been collected. What they're saying for this problem, plain and simply, is use that equation. Use this thing right here. Plug in x equals 4. So look, I'm going to very quickly write y equals negative 1.4x plus 10.7. We are going to substitute in an x value of 4. And at this point, tell you what, we're just going to get our calculator out. And I'm going to type in negative 1.4. And that's multiplied to 4. Anytime a number is next to x, that means multiply. Say plus 10.7. And it's okay to get a decimal. We're certainly seeing that right here. We get y equals 5.1. You can see that right there. So we're trying to predict the average number of problems. So we would say we predict 5.1 problems completed when a student sends 4 Snapchats. So really that's all you've got to do for a problem like this. You just have to pay attention to what your x and your y are. They're telling us that you got 4 Snapchats. That's an x, so we plug that in right here in our equation. You can see we did that right here. Let the calculator work it out, and then you'll be good to go. So really not so bad, especially when they're giving us nicely this equation. So let's go ahead real quickly and take a look at another problem. Look at this amazingly close problem right here. It's virtually the same problem, isn't it? We're jumping all the way over to number 20, and it says the graph below shows the number of meals eaten with family each week and the number of failing grades. The number of meals eaten with the family, that would be X. The number of failing grades would be Y. The red dots that you're seeing would be actual data that was collected. When you're taking a look, however, at the regression equation, you're going to see that what you've got is really an equation right here that's going to help us out. Y is equal to negative 1.3x plus 8. So it says use this equation for the line of best fit, also called the regression line, and determine the predicted number of failing grades when a student eats one meal. Well, wow, we've got one meal right here. What are meals? Meals are X. So we're going to let X equal 1. And what is our line of best fit, also known as our regression equation? Well, it's negative 3 times X plus 8. Plain and simply, guys, all we're going to have to do is plug in a 1 for our X. And again, let's get the calculator out. And we're going to go negative 1.3. We're going to multiply that to a 1. We're going to say plus an 8. And we'll get 6.7. So what would be the predicted number of failing grades? We could say we predict 6.7 failing grades, because that's what your Y value really is, for a student who eats one meal with their family. So you can see it's really very much the same type of problem that we just did. What are we doing? We're just finding an X value usually, and we're plugging it straight into the equation to make a prediction. Again, the red dots are the data points that are collected. What you're finding here, 6.7, at 1, we would guess that, 6.7 would be right over here on that green line. It won't be exactly the same thing as the actual data that was collected, and that's okay. We're definitely going to realize that the line of best fit is there to make a prediction. Guys, the very next problem, number 21, is actually a little bit trickier. It says, suppose that a young lady, Cassie, uses a set of data about nutritional values for her favorite energy drinks, and she created a table where X is the number of grams of sugar and Y is the number of calories. So, she's got that set up, but she's also getting another set of data. She found that there was a strong correlation between the number of minutes running and calories burned. And very, very importantly, now they're giving you a line of best fit, a regression line, as it's also called. So X is calories burned. That is so important. We don't have a graph right now to look at the X and the Y axis. We have to read very carefully. X is calories burned, and Y is the amount of minutes that would be spent running. So Cassie did all this work, and let's say that she has a friend, Sarah, who needs to answer a question. How long should Sarah need to run if she drinks her favorite energy drink with 35 grams of sugar? Well, 35 grams of sugar, I hope you're seeing right here. 35 grams of sugar. Sugar's right up here. Here's 35 grams of sugar. That's going to relate to 475 calories. So, what you did on this review, what you actually did on your summative also, or what you should have done on your summative, is realize that the 35 grams of sugar mean that she has 475 calories to be burned. She's got to use up that much energy. And she wants to know how long she'd need to run. Well, this is where, guys, we're going to jump away from the table and say X would be calories burned. Oh, this is what we've got right here. I can say, really, this young lady has 475 calories. Y would be the number of minutes that would be spent running. So we'd have Y is equal to 16x plus 28. Well, at this point, I think you've seen it happen time and time again. What we can do is just plug in that 475 plus 28. 16 times 475 plus 28. Let's take a look at this real quickly. A couple of ways you could do this. What a number of kids had happen on their calculators as they were working with this is they noticed that they got a fractional answer. Alpha y equals would in fact get you 1/6, and we're going to multiply to that 475 calories because that's what the x is here. I'm going to say plus 28, and this is what upset a number of kids. They were getting answers like 643 all over 6. That's an okay answer. That's how many minutes this young lady would have to run. To get a decimal, here's one cool way you could do it. You could say math and go down to number 2 and say, please convert that to a decimal, and then just hit enter. You'd get 107.16 or 107.2. So we could say 107.2 minutes. And guys, that would be the answer. That's how many minutes she'd have to run to burn off the calories in that, sugary drink. Another thing to bring up, you could have, if you ever wanted to, just take your number and just retype it out. 643 divided by 6, you get the same thing. But by the way, if you had a fraction like 643 over 6 as a final answer, that would be acceptable too. All right, one more problem. And it's very, very, very similar to what we were doing before. But this problem, ironically, it would have been the first one in your, summative review, but it does require an additional skill. Let's just take a look real quickly. It says teachers have found that the number of candies they give their students increases the number of problems they will complete without checking their phone during a block. And data is collected. The data, by the way, as you're looking here, would be the purple dots. And the numbers of candies given would be your X. Your Y would be the number of problems that would be completed. And of course, you've got your actual data. Those are your purple dots. That's called a scatter plot. They've drawn in nicely for us a line of best fit, a line of regression. And that's wonderful. What is very different is they did not give you the equation for the regression line. They did not give you the equation for the line of best fit. You're going to have to get the equation of the line of best fit, and that's definitely okay. You will need that, though, to answer what they are going to say. What if you had 9 pieces of candy? Wow, that's beyond even the graph here. You'd like to predict how many problems a student will complete without checking their phone. Well, here's this additional skill that we can have. Look for friendly points. 2 points that are on the line that are going through the corner of a little rectangle here. I'm going to highlight a little rectangle, right here. If you're going through one of those four corners, like here, 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 or here, that's called a friendly point, because we could, without decimals or fractions, represent that point. By the way, there's another friendly point that we could have. It's not even with a purple dot, but I do want to highlight it. It sure looks like 6, 7 would also apparently be there too. Now, that would be okay to choose that point of 6, 7. That would definitely be okay. I think most kids would just go with the first ones. This point right here is the point 0, 3. Your x is 0, your y is 3. This point right here is 3, 5. And, what you're really doing is you're finding your change in y. Going from 3 to 5, you're going up 2. You're increasing or adding 2. How about here? Your delta x would be going up by 3. And your slope is going to always be delta y over delta x. Okay? Now, we're almost there writing our regression equation. In general, we've used most of the time point slope. This is called point slope, and hopefully this is something that, having done this for many modules in a row, right now you're looking at that saying, hey, m is your slope, and of course we would have our x1, y1 as a point. We just found that our m was 2 over 3. Tell you what, I'm going to choose the point 0, 3 as my x1, y1. And then we can write this equation out. We can say y is equal to, well, what's your y1? Your y1 is a 3. We'll say 2/3 x minus my x1, which is a 0. And guys, we could even write that x minus 0, of course, is just the same thing as an x. You could write it this way. So here is your regression line. And of course, we now are able to do what we've done earlier. They're saying make a prediction. Make a prediction. So if you receive 9 pieces of candy, predict how many problems the student would complete. Candy is x. You can see that right here. So I'm going to go ahead and say let's let x equal 9 and work this out. 3 plus 2/3 times a 9. By the way, you could have done 9 minus 0 up here too, but here we go yet again. Let's just go ahead and use our calculator. 3 plus alpha y equals, we'll get 2/3. Now we're going to say multiply that. Oops, pardon me. I think I didn't hit the right arrow soon enough. There we go. Type in a 9. And you could see that actually that answer would be a 9 itself. And that is in fact correct. So we predict this student would complete 9 problems. And that wraps up our remediation video. Best of luck to you.